Okay, happy Monday, everybody. And today we have two sections, or we have four this week. I'm going to try to see how best we can do two of them today, and we'll see. If we don't finish some of it, we'll pick it up on Wednesday at least. So, little rundown of where we are this week. We are going to finish chapter 7 today. That's section 7.7, which is, I hope it's not going to be too bad. I think we'll be all right. And then we're going to go in chapter 8. And so this week we have 7, 7, 8, 1, 8, 2, and 8, 3. So we have four sections we have to do. The good news is a lot of chapter 8 we've already kind of done. I've already been showing you some of this stuff. It's considered right triangle trig, so it's kind of a jump from the unit circle. A lot of things, though, you're going to see are kind of repeats of what we've already had. And like I said, some stuff I've already talked about. So let's just finish up 7 first, and then we can talk from there. Um, okay, so chapter 7, last part. Product to sum to product formulas. And you'll see these are not much different than the last two sections. It's just a number of formulas that we can work on. So we've had the sum and addition formulas before. These are going to go kind of a combination of the two where we are having a product. We have two different sines, for example, of two different angles. And here is an equivalent formula to rewrite them. And essentially what it's doing is it's sort of like a derivation of our sum and difference formulas where you had to remember the sine, cosine, sine, all that stuff. And they're solving for something else. So you see all three of these. You have a sine, oops, sorry, go back. You have a sine of something times sine of something else. And the key is, of course, they're different angles. Okay, like sine of 45 times sine of 30. Without knowing what the angles are, we have a chance to break them down. And it's sort of like this. Well, if I already know these, I would just do the work right there. But it's usually where there's two angles we don't quite have memorized. So we do happen to know the sum and the difference of them. So that's kind of the opposite it was before, where we we knew each individual piece and then we found the sum and the difference. So now we happen to know the sum and the difference. We're going to go back here. So like I said, a lot of this is stuff that you've already had, just a different version. Okay, so here in the first one, without actual numbers, they're going to have sine of 5 theta, sine of 3 theta, sine of 2 theta, cosine 6 theta, cosine 4 theta, cosine theta. And we're just going to use the formulas to rewrite them in different versions. So, formula 1. And again, we're working sine 5 theta times sine of 3 theta. And remember the formula. We just had that a second ago on the previous screen. We have 1/2 bracket. It's the cosine of the difference of the two minus the cosine of the sum of the two. So simplify that. You get 1/2 cosine 2 theta minus cosine of 8 theta. And stop right there. That's pretty much all we need to do. We're not trying to do anything else. If we knew that, the actual value of theta, we can go from there. But in this case, it's a matter of trying to rewrite it into another form. So think about where all of these sections end, all of your homeworks, all of your quizzes. You have proofs of some kind. You have to prove something. So in order to do the proofs, it's all about finding equivalent ways to write something. In this case, if we happen to have two things multiplying, we can rewrite them as a difference of two things or a sum of two different things. And sometimes that's easier when you have individual pieces, like down here, you can work with them. Sometimes you prefer the first way where they're multiplied together. It sort of depends on what problem they're giving you. So formula, we're going to use formula 2 to get this one. Cosine of 4 theta, cosine of theta. And remember how this one works. It's kind of the same, but a little bit different. Go back here. Remember on this one, this is when we had two sines multiplied together. All right, and then it was 1/2 times the cosine of the subtraction of them minus the cosine of the addition. Well, here, it's close. You see, the only difference when you have two cosines, it's 1/2 cosine of the difference plus the cosine of the sum of the two. And there's our 1/2 cosine 3 theta plus cosine 5 theta. And that's all we're trying to do in these beginning examples, is just use the formula to get a rewrite. And then once you have basically go in both directions, now you can figure out what to use better to simplify a function or any kind of an expression out here. The last one is when you have a mix of the two. And remember, this one is addition, or you have the sine, 1/2, adding the two sine insides, and then another sine where you subtract the two. And this one's kind of weird here. Just because the 6 theta is bigger, it's not automatically the biggest minus the smallest. It specifically is written this way, where it's sine times cosine. Doesn't matter who's bigger, who's smaller. It's always sine first. And then you're going to do the sine of the addition and then sine of the subtraction. So it's always the little cosine angle. That's what's being subtracted over here. So that's the only quirk that I would say to watch out for. And here's our final answer, or not almost final answer, but remember, if you have sine of a negative, you can always pull the negative out, and it ends up with a negative sine of 4 theta there. Okay, so now these are going the other way, where we have sine and cosine. We're adding and subtracting two of them. Okay, so lots of formulas up there. The ones I'll tell you in this section 7.7, they're not the most essential going up using down the road. When you go to Calc 2, Calc 3, you'll see a little bit of these once in a blue moon, but for the most part, you do not really deal with these. So it's good to know how to do them, how to use the formulas, but I wouldn't say to go sit down and try to memorize these formulas, because there's a number of them, and it's not really worth your time. I'd rather you focus on the ones we had in the earlier part of chapter 7. Okay, so that being said, here's our, again, adding two sines, subtracting two sines, doesn't matter what the angles are, adding two cosines, subtracting two cosines. And why I say don't bother memorizing them is you look at all four of these, they all look almost the same. They're very similar. They're just slight variations, and it's very easy to swap one for the other by accident. Okay, so here we go, just kind of applying the formulas here. Here we have a subtraction of two sines. So remember that formula, number 7 they had, where it's 2 times sine of the subtraction of those times cosine of the addition. We end up with this, and then simplify it a little bit more to get 2 sine 2 theta cosine 4 theta, and that's all you need to do. Again, don't feel the need to do extra work in this particular case. It's just a matter of slowly simplifying these. A couple steps and that's it. So like I said, the difficulty is not too bad in this chapter, and you'll see when we get to the problems in a couple minutes here. So same thing here for the addition of cosines. It's cosine times cosine. Add them and then subtract them. And then if you can simplify, you do it. But in this case, that's pretty much it. So that's all there is to chapter 7.7. It's just a handful of formulas, and there's a lot of them, but it's just a handful of formulas that we have. So let me do this. Instead of going to the 8.1 lecture, let me get right to the homework, just to get a couple of these problems under our belt again, and make sure that we're all seeing them the same way. We're all looking at these identically, so that you know how to answer them. And I'll keep this as a reference, just so we don't have to keep sliding back. But again, summarize, you have these 3 formulas here when you're multiplying 2. You get these when you're adding and subtracting, and that's it. 9 formulas. I know that's, I won't say a lot. It's not even 9. It's these 3 and these 4. There's only 7. I'm not sure why they call them 6, 7, 8, 9. Regardless, you don't have to know the numbers. Just know how to work with the formulas. Okay, so let's look at a handful of these examples. Here we have a sine of 315 degrees times the sine of 15. And remember, the goal here is that we don't know these angles by heart, okay? We know 330, we do know 315, but 15 wasn't one that we normally know. So that's one that if you already figured it out, you can just go plug these 2 answers in there and then multiply the answers, and you'll have your result. But if you don't, like again, we know this one, square root of 2 over 2, I can replace that with negative root 2 over 2. The 15, though, is not one that we had. You learn from previous sections that you can do the addition or sum of the, like 45 minus 30 and get that 15. So if you did it that way, you can just multiply those answers. The other alternative is, like I said, you can use our new ones. So it's a little bit of a review, Kayla, but it's more of they're teaching us these brand new formulas. So let me pull those back up. Where is it? Right here. So even though you can do this problem in another way, from before, like you didn't have to know chapter 7.7. You could have done this problem prior to today's lecture. This is giving you a plan B, another alternative. So you see here, if I take the formula, sine of alpha times sine of beta, and it's all this, the 1/2 cosine of alpha minus beta minus cosine of alpha plus beta. Okay, so let me move that out of the way. Okay, so the object here is to make sure you plug everything in properly. So the alpha is my 315 degrees, the beta is my 15 degrees, and that's what I'm going to replace every one of these pieces with. So we get a 315 minus the 15 minus cosine of 315 plus 15. And I'll clean this up a little better here. So we have a cosine ultimately of 300 degrees minus a cosine of 330 degrees. Now, I can make the argument right now that it's not always faster. So I'm not saying this is the best way. That's why I was saying section 7.7 is not the most essential, but it is a way to give you an answer, another route here. Okay? So we're looking at our 300 degrees. Cosine of 300 degrees right here, and cosine of 330 right there. Okay? So we have our 1/2. This is a 1/2 minus root 3 over 2. Okay with me so far? Any questions on anything that we've done here? Okay, now it's our algebra. That's all this is. We get a 1 minus root 3 over a 2, and then 1 minus root 3 over 4, and that's about as far as we can go. And remember the instructions. I didn't read them out, but simplify your answer. That's what we did right here. Include the radicals, integers, or fractions, and it doesn't blatantly say it, but no decimals. Okay, because I could easily type in 315 and sine of 315, sine of 15, but they want the exact answer, so that's this 1 minus square root of 3 over 4. Now, another trick, remember, I was showing you guys this last week. Yeah, let me pull up these formulas, sorry. So those are the ones we just used for everyone who's looking. And just want to get my calculator. Remember, I can go and plug this into a calculator, even though it's not the actual exact answer. It's something just to make sure that I'm on the right page. So when I do 1 minus square root of 3, I get this. Divide that by 4, I get this. So I get a negative 0.183. Now, I won't do this every time, but I'll do it once in a while just to make sure that we're all seeing this. So what I can do is, I know this original problem was sine of 315 times sine of 15. So make sure you're in decimal mode. Sine of 315 is this. Multiply it by sine of 15. And you see we get the negative 0.183. That just confirmed that we did everything correct. We did our algebra correct. We used the right formula. That's how I know, without even checking, I know we'll have the correct answer. Okay, any questions on number 3? And we'll look at number 7. Okay, so let me clear this off. Okay, so on this one, they want you to express the given product as a sum of sines, a sum containing only sines or cosines. So it's a sum, this is a product, we need to convert it to a sum. So looking at my formulas right here, it's the same thing. It's just like this first one right here, the one we just used. So let me keep this kind of close. Okay, so if we have, and I'm not saying you have to write the formula every time, it helps you to memorize this, it helps you to learn this. It's not essential, but sine of alpha, sine of beta equals a half cosine of alpha minus beta minus cosine of alpha plus beta. And we're looking for the sine of 13 theta sine of 14 theta. And I know that didn't look exactly clear. It looks like a 130 and a 140, but they're thetas. Now remember, you have no idea what theta could be. It could be 1 degree, it could be 90 degrees, so you can't automatically simplify this. Like a lot of people look at that and think, well, can I subtract a 180 or a 360 or scale that back down? Because you don't know what theta is, you can't rewrite this at all. You really have no idea. This could be the simplest form. So that's why we're going to this here. We're going to take cosine of the subtraction of the two. And remember, it's, alpha minus beta. So there's your 13 theta minus 14 theta. And here we're going to add them up. So we get 13 theta plus 14 theta. And then it's all about cleaning this up as best you can. Here we get cosine of negative theta minus cosine of 27 theta. And then I can distribute. I'll also look at this negative right here and remember the rule that when you have a cosine of a negative, remember what that does to the negative, it just wipes it away. So I can just, instead of calling that cosine of negative theta, I can just call that cosine of regular theta. It's the same thing. And then I forget if they want us to distribute, so I'll just do that. Now, unlike the last problem, unfortunately, we don't have a calculator to check because theta is an unknown. This is as far as I can go. Let's read the directions and make sure. Simplify your answer, include any radicals, use integers or fractions for any numbers. So it didn't really tell us much, but it's just a rewrite of all this. So we have a 1/2. Cosine of theta minus 1/2 cosine of 27 theta. And that's it. So like I said, like with the examples, there's not a whole lot, like even all this, I didn't even have to write half of these steps. It's really just a case of, can you identify which formula to use and can you plug stuff in? And that's more important than you think, because later on in your classes, your math classes, you're at some point going to just get a brand new formula you've never seen in the homework or the test. And the idea is, can you know what goes where? Can you apply it even though it might be brand new to you? And that's what a lot of this is what we're doing here, is I'm just throwing you a bunch of formulas and seeing if you can adapt and learn, okay, which one do I use? What goes where? What do I get? Okay, questions on number 7. Let's look at number 11 here. Express the sum or difference as a product of sines or cosines. So remember, look at my formulas here. These are products that we convert into sums. We want to go backwards where they're giving us a sum, like here, and we need to convert it to a product, which is what this is. So here we have sine plus sine. Make sure you identify it's that first formula again. This is the one I'm going to use. And just like before, I'm going to go and rewrite the formula first. Okay, start with the formula. And I've told you before, that helps you to memorize it. The reason I'm telling you to do it here is it makes it easier to plug things in. So we have sine of alpha plus sine of beta. That's going to be 2 sine of alpha plus beta over 2 cosine of alpha minus beta over 2. And our problem is sine of 3 theta plus sine of 5 theta. So obviously getting your formula is the priority, getting the correct formula, but the next most important thing is you have to know that's alpha, that's beta. make sure you identify what's what. So when I go plug things in, I know what goes where. So we have 2 sine of 3 theta plus 5 theta over 2, cosine of 3 theta minus 5 theta over 2. Now remember, these 2's are all inside of the angle part of the trig function. They don't cancel with that front 2. So this becomes 8 theta divided by 2. That'll give me a 4 theta. And this is negative 2 theta divided by 2. That should give me a negative theta inside of the cosine. And my last part of simplifying is like the last problem. When you have a cosine of a negative, it's the exact same thing as cosine of just regular theta. And that's our product right there. That's all I need to add. Now, I'm going to enter the step right before just to show you all what happens. And I'm also not going to put a parenthesis. I don't think you need a parenthesis around your 4 theta, but let's just say I, try it out and see what happens. But I'm going to put a negative theta. So to be clear, I'm entering this line right here to see how picky the system is. And like I said, if you want to try this homework, this is a good time when it doesn't count just to see what they check, and they should mark me wrong, and they did. Okay? And now let's enter the actual answer. We have that right there, and see that difference made it work. And that's what they mean when they say simplify your answer. This technically, even though it's right, it's not 100% simplified. When you have a negative inside of your trig function angles, you can see what you can do to pull it out. Remember, for sines, you literally pull it out. For cosines, it just goes away completely. All right, so there's our answer, that last step. Questions on number 11. Okay, let's look at number 15. They want you to establish the identity. So now we start getting to the bigger problems here. And just remember that every one of these identities, you're doing the techniques the same way. Okay, nothing has changed in how you do them. We're trying to get the left side equal to the right side. The difference is we have more tools to simplify with. So I have sine of theta times the bracket of cosine theta plus cosine 3 theta. We want to get that equal to negative cosine theta sine theta minus sine 3 theta. Okay, so as you're going through this one, I'm going to get more room on the screen to make sure I copied everything right. All right, so we want to make these equal. So the way that normally works is we're going to take the left side and make it equal to the right side, or the right side equal to the left side. Now I'm looking at these, and I'm purposely looking at my different formulas. When in doubt, I'm just going to pick the left side. That's just where I tend to go, but it doesn't matter which one in this case. So I look at my different formulas here, and this is how you have to try to break it down. I see sine times something, but remember, over here, it's sine times sine times cosine. I don't have that. I've got 2 things in there. Okay, so I have a couple of options. I can distribute the sine, so I'll have sine cosine plus sine times 3, or cosine 3 theta, and that would give me, excuse me, a couple of these formulas. Maybe that'll end up that way. So that's one option. Another option is inside I have a couple of cosines. Maybe I can do that and see what happens. Okay, and I can replace that with these. So it doesn't matter which one. I don't know the actual answer here, so I'm just going to go take a shot. And let's say I'm going to go with this first one. Okay, that formula in the middle, cosine right there. Now watch as I replace this. I'm using this formula right here, very bottom right of my screen. I have a cosine time. Oh, sorry. I picked the wrong slide. Go back. I'm looking for that one right there. The cosine plus cosine. Inside the bracket is what I'm trying to replace. So the one I have circled in pink there, that's what I'm going to go and replace this one with right there. So that's the goal here. So let's see what happens. And again, as these proofs get more complicated, you might have to just take a shot like I'm doing. And if it doesn't work, you have a plan B. That's why I kind of talked to you guys just a second ago about what are my different choices? What else could I do if this doesn't work? So I'm already looking ahead and thinking, well, if this doesn't work, I got another option. So let's just see. All right. So I'm going to replace this and look at my formula. Remember, I have two cosines. If I need to, for the purposes of my formula, there's my alpha, there's my beta. Okay, and I'm going to replace with all that right there. So follow along what I have here. I get 2 cosine of alpha plus beta over 2. So that's 4 theta over 2. That's a 2 theta. Times cosine of alpha minus beta over 2. So that's theta minus 3 theta is negative 2 theta over 2. That's a negative theta. So it kind of looks like that last problem I had. This becomes 2 cosine 2 theta cosine theta. Because again, the negative just goes away when it's inside of a cosine. Excuse me. So now I'm looking at this and going, okay, I don't see exactly it looking like the other side, but let's see if there's some way to rewrite, okay? So if I was to multiply all this out, I now have 2 cosine 2 theta, cosine theta, sine theta. Now, every time I'm doing this, I'm still peeking back up here and trying to think, well, how can I get that? Okay, can I make that work? And another way to do this is, let's just say, you're not supposed to work both sides, but I'm thinking in the back of my head, well, if I can get to this, then I can just factor to get back up to here. So I'm kind of keeping both these in mind of let's see if I can make either of these happen. Okay, now if I'm looking at this, I'm saying, wait a minute, this is kind of, there's a distribution going on over here. There's 2 separate terms inside. Now I have one big fat term. That sort of has changed the narrative where I am. It's like, well, I don't know if I like this one because how do I get from 1 term down to 2? I do have the option of these other formulas right here. When I am multiplying something, it does produce 2. So maybe that is the way to go. Maybe I just got to pick 2 things that I'm multiplying and maybe something will go away. It's tough because I have 3 things over here. Cosine 2 theta, cosine theta, sine theta. Which one do I pick? So I can look at this and I can just try one. Now what I'm going to do is I'm going to pause and say, you know what? I don't like the way this is going. So let me go back to the very beginning and let's see if I can do something a little different. Let's try distributing first. Remember that was my plan B? And I'm doing it this way to show you that you're not always going to guess right the first time. Okay? And maybe we did guess right. Maybe this way that I'm doing is going to be even worse and we're going to go back. This is also why I didn't erase what I just did. I'm kind of like, I'm at the point of, well, let's see here. I've done 3 steps. I'm going to hold on that one. And if what I'm doing right now, plan B, if this is no good, then I'm going to scratch that. I'm going to pick right back up where that hold button was, and let's see if that's going to work. So don't cut yourself off. Don't quit anything. Emily, you asked, how did I get the 2 cosine theta term? Oh, you're talking about this one right here, right? And all it was this times this times this. It's one big multiplication problem. So I just stuck the 2 cosine out front. It doesn't matter the order. All those things are multiplying together. It's like one big term of multiplication. So you could put the 2, you should put the 2 in front, but I could have put 2 sine cosine 2 theta cosine theta, as long as all those pieces are there. The sine, the 2, the cosine 2 theta, and the cosine, all 4 things are multiplied together. Okay, so back to my plan B. Let's see if this works. Now, when I have this, now I'm again trying to get to this right side. I have 2 products. So what that's going to be is I'm going to, let's call this number 1 and number 2. In both cases, I have a sine times a cosine, so I'm going to use, happens to be this one that I have in purple right there at the bottom. Okay, let's just see what we get here for both of them. Now you see, your first couple of problems just get you to use the formula. Now you're going to be doing the formula multiple times in one step of an identity. So you have to be able to do some of this in your head. So this first one becomes 1/2 bracket sine, and I'm going to do this in my head here. It's alpha plus beta, so it's theta plus theta. It's a 2 theta. Plus sine of alpha minus beta, that's a 0. Okay, alpha minus alpha, theta minus theta, alpha minus beta, whatever the case, that comes out to be a sine 0. It doesn't mean it automatically goes away. It does in this case because it's sine, but that's what we get. So I'm not going to try to oversimplify right now. I am literally just doing my formulas. So in the next case here, we have sine alpha times cosine of sine of theta, cosine of 3 theta. So I'm going to add the two angles, sine of 4 theta, and then plus sine of theta minus 3 theta, that's going to be minus 2 theta. So let me pause for a second and make sure everybody sees I've just applied this formula twice, one for each product, to see what we get. And you have to be very meticulous, you have to be very careful. Don't try to rush through this, because all it takes for a proof or any problem that's this many steps just takes one little error and nothing will work. Nothing will cancel like it's supposed to be. So you have to make sure here. All right? So now I've got a half. There's a half in front of everything. And that half is probably one of the most annoying parts of this. So we're looking at this 1/2. It's going to distribute to all pieces. So let me see here what I can get. And let me simplify a little bit more inside. So this is a sine of 2 theta. The sine of theta, 0, becomes nothing. So that's gone. And then over here we have a sine of 4 theta. And then remember, when you have a negative in front of it, it becomes a sine, a negative sign is what I'm trying to write here. The negative goes right out front. And that's important because when I distribute this, I get a 1/2 sine of 2 theta plus a 1/2 sine of 4 theta minus a 1/2 sine of 2 theta. And then if you see already, this and this are identical. They're going to cancel off. So we're getting somewhere. We've simplified it, but we have not proven the identity yet. We got to figure out what we do next. So let me pause here. Oh, applied it twice. Emily was right here in this, this, where this number 1 is. I used the formula to make it into this 1/2. And then where this one is, I applied the formula again to make it into this one. So that's where I applied the formula 2 different times for 2 different aspects of that side. Okay. So now we need to figure out where we're going next. We're close in the fact that we've made this simpler, but look what happened. I'm still trying to get back up to here. So if you look at every formula we had today, we had 2 things multiplied together, a product, and we can write them as a sum. We had over here a sum or a difference, and we were able to make them into a product. What we don't have a formula of is when you have one single term. So it was nice that everything canceled out, but it didn't it went almost too far. Okay? So let's look at, like I said, I wanted you to see where you're going, where you have no game plan, as in there's no formula you're going to use every time. So remember what the other game plan was. Remember, this is our problem. In a proof, they're not going to have you show every single step. They have these little multiple choices, and they want you to see which one best matches what you did here. So look at what they did. They're working on the left side, like we were doing. And the first step, let's just kind of check the math here. All right. They took the inside and they made it into a product. So this one right here, 2 sine 2 theta cosine negative theta, or 2 cosine cosine, it looks like they were doing what I was starting right up above here. Okay? That was what I was telling you earlier, where we tried one way, I didn't like it. We held it and we tried a different way. That went too far. So let's go back. Let's go back to this blue spot where I said hold and let's see where we're at. And number one, refresher of what we did. We took that bracket and we rewrote it as a product. 2 cosine 2 theta, cosine negative theta. Now look at our choices up here. See if I can get them all in the screen. Let's see if any of these match. And I'm talking literally about this part right here. All right, 2 cosine 2 theta, cosine negative theta. So this one is wrong because it had a sine. This one has 2 cosine theta. That's wrong because it should be a 2 theta. This one has the correct one. So just that alone, I think that's going to be the right one. Let's just follow their math and make sure everything is good. So they did this line, which matched ours right here. They got rid of the negative. And then look at what happened next here is, instead of them pulling everything out like I did, what they did was they rearranged it to put the cosine out front. Make sure I'm seeing what we did here. Sine's there. Okay, so they did a very unique thing. Let me scroll this up so you can see where we're going on part C. Okay, so let me erase a couple things and then kind of break down exactly how this went. And I don't want this to be that easy where you just look at it and in the first step you eliminate 2 and you have your answer, but we do know it's going to be C just from that. The first 2 are wrong on their first step, but I still want you to get the understanding of how this came about. You know, where did they get all these answers from? Because later on you're going to have to show this. Okay, I'm going to clear mine since we are at the same point, but they have a little bit of a different step here. Okay, let's see if this works. Okay, so where we are. So you look from here to here, that was just like what we had. But now I want you to know what happens when you go from here down to here. Okay, it's an interesting thing. Number one, they pulled out this cosine theta right here. They put that out in front of the bracket and they put the sine on the inside. And then they also put a couple negatives there. Okay, now why they put the negatives, that's the interesting story. They did skip some lines here, but let me just pick up right where they are. They have a negative cosine theta, negative 2 sine theta, cosine 2 theta. Now, you notice what's inside there, that's a product. 2 things multiplied together, the negative 2 sine theta inside, the cosine theta inside, and then they end up with all this. Now, if you look at your formulas, where's our products? Okay, right here, the third line. It's a sine times cosine, right here. Okay, why they left that 2 there? That's the interesting part, is because if you have a 2 in front of it, it's also 2 right here, and you don't need that 1/2 stuff anymore. That's why they left that 2 inside, is because it fits right in with that part. So what we get is 2 sine theta cosine 2 theta, and there's a negative in there too, which means I can write this right. Yeah, there's a number of steps. Let me just do it a better understanding way for you guys here. We're going to apply this formula. So that one on the very bottom that I sort of have highlighted. So this stays out here. And I'm going to leave the negative for now, and I'm going to replace all of this. In fact, I'm going to leave the negative 2 there as well, the whole thing. Let's replace just this. Sine times cosine. Okay? Oh, third formula. That one right there. Okay? So you look at the formula. It's a half. I can get my pencil to write here, sorry. Half of sine of the addition of these, so that's a 3 theta, plus a sine of the subtraction, so that's a sine of negative theta. Questions? Now, I'm trying not to write too much because I just want to simplify everything. I'm trying to simplify the way they did. It's not exactly the way I would do it, but it's getting there. So we have a minus, the 1/2 and the 2 cancel. So we have a minus sine of 3 theta minus sine of minus theta. Okay, that's me distributing the negative throughout both pieces. And now we have a minus this right here. Remember, when you have a negative, the negative comes out front, so that cancels off. And that's how you get a positive sine of theta. So you see, that is that exact step right there. Just switch the, flip around those two terms. So it's one of these where they're looking way ahead. I don't expect you to do that right off the bat, but just kind of see the steps they took. All that to show what you kind of already knew is that C is our answer. Okay, switching things around. That's the big theme here of what you need to do for these problems out of 7.7. All right, let's look at another one of these just to kind of make sure here. Now, again, they got the 4 options of what it could be. We want to establish this identity. We have 1 plus cosine 2 theta plus cosine of 4 theta plus cosine of 6 theta. We wanted to make it equal all of this. Okay, so 4 steps. They all pick the left side, so we're going to simplify. We're going to think, okay, we're adding a bunch of things. This is going to be our second set of formulas right here. And we're adding a bunch of cosines, so we're talking about the third formula. Okay, let's see if I can leave that on the screen and still show all of our choices. Okay, so we're using this one right over here, the third formula. That one's the one we're doing. We're just adding them. So now you got to figure out, I see a lot that's being added. I have a cosine 2 theta, a cosine 4 theta, a cosine 6 theta. Which ones do we add up here? Okay, there's a lot going on. So start looking around and seeing where everything is coming from. Okay, and I want you to look at all 3 of them, as in, all 4 of them. This one, that one, and that one. Now, in each case, you want to see, did they do something that was mathematically possible? Now, there may be a step in here, and it's like, I don't know how they got that. That doesn't mean it's wrong. It doesn't mean you cross it off. If you see a glaring mathematical error, then you can cross it off. But until then, you can't cross anything off. So we have to kind of see, well, where's my formulas? And keep in mind, they don't always show every single step. That's the filling in the blanks that I was doing earlier. So we're trying to see what's going on. Now, at first glance, I can look at these and say, I don't know how they got this. I don't know how they got that. I don't know how they got that, how they got that. Because we go from 4 terms down to a 1 term out front factored out and 2 terms inside. So there's a lot of reduction in here. So I'm not going to just make a decision right now. I'm going to go and work this off to the side, and let's just see if what they have appears. Okay? So let me go with, okay, we have 1 plus cosine 2 theta plus cosine 4 theta plus cosine of 6 theta. Now, another thing before I pull the screen down is look at what happens in the end. We're trying to get this where it's all one term. It's a bunch of things multiplying together. We're trying to somehow get that from this, which means these four individual terms, don't forget the one, they all have to go away. They all have to, as in go away, as in combine. So you got to think, how can I combine two things? Well, these formulas will help us right here. This might be the way to go, but I'm far away from it. Now, the other issue right here, lingering issue is what I'm trying to say, is this number one. I don't have any formula that combines a number with a trig function. However, see if anybody sees this, I can rewrite that as cosine of 0 theta. You recall we had that earlier with the sine of 0 theta, which was the number 0, because sine of 0 is 0. Well, cosine of 0 is 1. So if I call that 0 theta, that's actually 1. So that's all I did in this first step. Now what I'm going to try, just because I don't know what best way to do this, let's just try to put these together. Let's go ahead and combine these with this formula. Now, another way to possibly do this is I could combine these two and these two because they both add up to be 6 theta. That might be another plan I'm going to do. Okay, so I'm keeping that again in the back of my head of, well, maybe I'll rearrange the terms because it doesn't matter which two. But let's just go with these in order and see what happens. Okay, I like to just kind of roll the dice a little bit and see what we get. We get a 2 cosine, add them up. That's 2 theta. And it's 2 theta divided by 2, so it's just theta. And this is going to be alpha minus beta, so that's a negative 2 theta over 2, which is just going to be, add those up right? Yeah, same thing. Okay, and I'll clean this up in the next step. But that's my first part. You see, again, we add the two angles right here. That's my alpha, that's my beta. Add them up, we get a 2 theta. Then divide it by 2, that's why we get a theta right there. Over here, we subtract them. 0 minus 2 theta is negative 2 theta over 2. And like I said, I will clean that up in the next step. So here we have a 2. And then again, we're going to say cosine of add the angles and divide by 2. So 4 theta plus 6 theta is 10 theta. Divided by 2, we get a 5 theta. And now we subtract them and we get a negative 2 theta over 2. And now let's clean some things up here. 2 cosine of theta, cosine of negative theta, which is just cosine theta. Everyone see that? That simplifies to be a cosine of negative theta. When it's cosines, you pull the negative away. And now we have a 2 cosine of 5 theta. And again, there's going to be a cosine of theta right there. Okay, so we've sort of simplified this a little bit. They're different still. And now we got to see what happens next here. We cannot just apply this formula again, by the way, because there's too many cosines. It's only when you have one cosine added to another. So I'm kind of stuck, but I got a plan. Plan is, look and see what you have here. See if anything opens the door. If not, let's go on to the next. Oh, wait, before I go on, look at what I have here. Remember my 4 options? Let me scroll up a little bit and show you. Okay, let's go over here. Look at my 4 options, and I want to see, do any of these look like what I'm doing? And the reason this is good to check is, if I see nothing, I may be going the wrong way. I may need to try this again. So I'm just going to do a quick pause and check where I am. So here they have a 2 sine parenthesis cosine theta plus 5 theta. I don't see that anywhere, but it doesn't mean it's wrong. Here they have a negative 2 sine theta. Okay, I can see the 2. I don't see a sine, so again, I'm not sure there. Here they have a 2 cosine times a parenthesis cosine plus 5. That looks a lot like what I have, and let's look specifically. it looks like we can factor out the 2 cosine. And you see how we get the exact same thing? That's looking nice. Okay, the last one is close except for they got sines in there. I don't know how they got that. So again, I'm going to put a mystery here, but I am gravitating toward part C. Okay, so that's giving me some vindication. Okay, I'm feeling good because I'm at least matching one of them. Now, also keep in mind that when they write these multiple choices, they know how to write them in a way that people may make certain mistakes, tend to make these mistakes, and that sometimes is there. Okay, so let me make sure here. Emily, you're asking, how do I get the 2 cosine? Oh, yes, I'm sorry, going right back up here. Okay, you're talking about this. I'm guessing that one right there, how I got that. And if that's what you're wondering, it is all from this formula right here, because the 2 is part of it. So I have a cosine plus a cosine plus a cosine over here. The formula is 2 cosine from all this. And same thing with that one right there. I think that's your question. I hope that's it. If not, tell me, and I'll clarify some more here. Okay, so now I'm going to try to keep going with what I think we have something right. And remember, our goal is to make this all one term. Now, what's good is now I am going to be able to apply this right here. Okay, you see that in that parenthesis, I have a cosine plus a cosine of theta plus cosine of 5 theta. I'm going to do that in the formula. So this will not change out front, but inside that formula, I'm going to go with 2 cosine, add them up, we get a 6 theta over 2, and then subtract them, we get a negative 4 theta over 2. Yes, that is correct, Emily. I used the right side of that formula. So this, I used it here, and then I used it again right there. So yes, 2 times because it took care of 2 sums. And of course, I used it again right there. So now let's clean up what we have. Looks like we get a 3 theta for this. And then remember, this is a negative 2 theta, which becomes just 2 theta. Okay, and if I clean this up now, I get a 4, I get a cosine theta, I get a cosine of 2 theta, and I get a cosine of 3 theta. And after all that, we do have our answer. So again, I'm doing this. I have no idea how we're going to get there. What I do from my experience is I'm just going to pick what I think is the best path. Sometimes in class, I'm going to pick an odd path just to show you guys 2 different ways. But pick some way and start going, but don't go too far. Go back and check these multiple choices, see which one looks like yours. And that looks like it was our best answer. So should work. And that's our one right there. Okay, but for these proofs, these identities, you just have to go in and try some things out. And sometimes after you do a few steps, you start to see the end. You see where you're going to go. Okay? So let's go to, if there is a number 23. Yeah. Derive the sum to product formula of cosine plus cosine equals all of this. Okay, so it's the same formula. They say derive it. What that means is they want us to show why this is true. So it's a given over here. So you can't just go and say, oh yeah, this is the formula, we're done. We know it's true. They want us to try to figure out, well, how in the world did you get it here? Okay, so if you look at this, get all these pieces here, and it's, oh yeah, there are 4 parts. Okay, which is correctly rewritten expression. So try to see where they got these from. Okay, look at our different pieces, and it looks like, I think they're just asking us here to, okay. Okay, I know what's going on. I'm sorry. So we start out and there's letters everywhere. They're saying that if you have cosine times cosine, what does it equal? Remember this right here. We're using that original formula. So it's 1/2 cosine of alpha minus beta plus cosine of alpha plus beta. So here they all have a 1/2, not the first one. This is just that right here. It's cosine plus cosine right here. Yeah, and it's tough because you have alpha plus beta, you have all this stuff going on, but let me show you what's going on in this formula. So let's start with this first piece. If you have two cosines together, you take that first angle minus the second. Well, here is the first angle. Here is the second. That's what you're putting right here, okay? This is the one we're looking at. Actually, these aren't. Okay, so I'm trying to do this the fast way, but we're supposed to take these two angles and we're going to add things up. So it's a little bit off on what they did. They've switched positions here. But if you look at our formula, we're supposed to subtract the two to start. So it's going to be 1/2 cosine of the first angle, which is this, minus the second angle. And what's awkward is that whole thing is the first angle. This whole thing is the second angle. And that's what I am subtracting right there. And then you have the cosine of the angles added together. Well, here's my first angle. Here's my second angle. And that's what we have. So keep in mind, that has sines, that's out. That has just one, that's out. This has a subtraction, which is wrong because it's supposed to be an addition. But it looks like they got it backwards, but it's okay because when you're adding, you can switch positions. So D is our correct choice. And this is only part one. Okay, that's our first part. And now we have to go, and I'm going to clear this just so we can see. Then we have to simplify to get this following result. Now, so look at what they did here. And this is like you're decoding, you're trying to break a code here sometimes. So we found this right here, okay? We found that. Then what they did was they multiplied both sides by 2, okay? And then, so that's how you get this part. They didn't make that into a 1 in front, but you have alpha plus beta over 2 plus alpha minus beta over 2, all this. They want us to simplify these two parentheses. That's what's going here. In fact, not just the parentheses, the tops. So let me start with the first one. We have alpha plus beta over 2 plus alpha minus beta over 2. They have a common denominator, so I can take the two numerators and add them together. And then what happens is the betas will cancel off, and we're left with 2 alpha over 2, which of course becomes regular alpha. But what's tricky is they want to know what that is over 2, so we have to go back a step and say that's going to become a 2 alpha. Even though, yes, it's going to simplify into a regular alpha, we got to put the 2 alpha right there. And then we're going to do the same thing for this second part. And let me see if I can do this, save a little bit of work. Okay, so the second part, right over here, we have alpha plus beta minus alpha minus beta. So this becomes alpha plus beta minus alpha minus beta. So when I distribute things, we get alpha plus beta minus alpha plus beta over 2. The alphas cancel this time, and we have 2 beta over 2, or just beta. But again, they want just the numerator when the 2 is still there, so that should be a 2 beta, and there's our answer. So you have to kind of follow the procedure that they're asking, what they get specifically what they're looking for. So now, complete the division. Oh, okay. I'm guessing we just got to simplify this into cosine of alpha plus cosine of beta. So complete the division. You got to follow it literally. The division is just these little divisions right here. 2 alpha over 2, 2 beta over 2. And then therefore, 2 cosine of alpha plus cosine beta equals... I guess we're done. Sorry. Okay, that was it right there. That was our problem. Yeah, because we had to prove this. We were going backwards. We took this and we're proving the beginning part. So it was an interesting move. But that's it for this one. So it looks uglier than it is. It still requires work, and you just have to follow through the steps and see what exactly they're trying to point out. Okay, so now we're at the 8.1 stuff. So I'm going to pause on the homework, and I'm going to jump back to lecturing with the PowerPoint, show you guys the 8.1 stuff here. Now, like I was saying, Chapter 8 should be nicer because a lot of this you've already had. Some of it, though, may be a little bit new or a little bit of a rendition of what we had before. So it's right angle trigonometry. So some of this stuff, like I said, you already kind of know this stuff. B over C, A over C, all this stuff, it's the same letters. Now, this is a normal triangle. When you get your alpha, think of what sine is. It's Y over R. They're just calling it B over C. Okay, doesn't matter. I tend to go with X, Y, and R. It's the same thing. But what I do like about this description, these definitions, is they use the words adjacent and opposite and hypotenuse. So you know the hypotenuse already, the long side of a right triangle. It's always still a trig function of the angle. Notice it's sine of theta, cosecant of theta, cosine of theta. So everything revolves around where this theta is. The hypotenuse is always the long side across from the right angle. Now, adjacent side is the side that's touching the angle. When they say adjacent, it's adjacent to the angle, right next to it. And the opposite is a side that's furthest away from the angle. And that's important when you see something like this. So you have to be able to identify what's what here. Of course, there's the hypotenuse, but remember, your adjacent side is touching the angle. The opposite side is over here. And you may get a triangle like this. Sorry, that's supposed to be a right triangle. But if this is your theta, remember, that's still the hypotenuse. This is actually your opposite. It's not always the vertical line. It's not always like where a y would be. It's who's touching the angle. That's the adjacent. Who's opposite of the angle, that side is the opposite. And that's what we use to get these formulas. So your right triangles can be anywhere. They can be a lot of different places. You just have to get that perspective. And just remember, hypotenuse is the long one, the easy one. Adjacent is always the side that's touching the angle in question. Wherever your theta, your alpha, your beta, your omega, wherever your angle is, you're always looking at what's touching it is the adjacent. What's not touching it across the triangle, that's going to be your opposite. Okay, so that being said, look at a couple more of these here. Maybe. Okay. Find the value of each of the 6 trig figures of this figure. All right. So this is going to be similar in the fact of, in order to get the 6 trig figures, you have to know all 3 sides. So we know the 5, we know the 13. We have to first do our Pythagorean theorem, right? So we have the 5, we have the 13, and remember, of course, the hypotenuse is 13, which is our C value. And your A, for adjacent, that's the side that we already know it's touching it. What we don't know is that opposite. So we go do our Pythagorean theorem, and you should get 12. There's your B. There's your full triangle. Now you should be able to get all 6 trig functions. Sine is 13/12, cosine is 5/13, tangent is 12/5. Oh, sorry. Cosecant, 13/12, secant, 13/5, and cotangent, 5/12. All right. Nothing new in this case. It's just a couple different words here. All right. So I don't know why it says help on the middle of the screen. I don't know. Sorry. Somebody wrote this and they weren't happy with their job, so ignore that. Okay, a rain gutter is to be constructed. Remember we did one kind of like this before, and it's got aluminum sheets 12 inches wide. After making a marking off a length of 4 inches from each side, it's bent upward, and the area is this formula, 16 sine theta cosine plus 1. Find the area for 30 degrees, 45 degrees, 60 degrees, and it's not really anything new. It's the same stuff we've been doing. We know sine of 30, we know cosine of 30. We get that value. For your square inches, for 45 degrees, plug them in, we get 19.31, and for 60, we get 20.78, just to kind of show you out of the three, which is the best one. Okay, now, I don't know if those slides really should have been in here, but regardless, we already knew it. Complementary angles. So this it's a little bit different, but we've had this before. If you know the sine of one, and just kind of let's look at sine. Okay, so if we're taking sine of, let me show you this. We're taking sine of b. It's going to be, of course, this over this. Now, if we reset this and say, well, let's look at the cosine of A. For cosine of A, remember, it's the adjacent, which is B, over the hypotenuse, which is C. They're the same. And basically, that's always going to happen when you have your two angles. They're going to be partnered up. So sine and cosine of the two individual angles, obviously not the 90-degree angle, but we're talking about the two other angles of any triangle. If you take the sine and then you take the cosine of the other one, they're going to be the same. All right? If you take the tangent of one and the cotangent of the other, they're going to be the same. You take the cosecant of one and the secant of the other, they're going to be the same. You're going to get this partnership. Now, this is not really anything you have to memorize. It's just kind of pointing out some interesting facts, but it does help you out, okay? So with the theorems, if you have sine of 79, remember, complementary means they add up to be 90 degrees. Go back to that picture. A and B, because the triangle has 180 degrees, and we know the right angle is 90, the A and B are always adding up to be 90. So in this case, if I have sine of 79, the complementary angle is 11 from taking 90 minus 79, and that's going to be equal to the cosine of 11, and sine of 79 degrees are the same. That should say degrees right there too, by the way. It's supposed to be degrees. Okay, here we do the exact same thing. If you know the tangent of something, you can find the cotangent of its complement. Well, instead of 90 degrees, we take pi over 2 and we subtract that from it. Get a common denominator. We get, I think, 9 pi over 18 minus pi over 18 is 8 pi over 18. That reduces down to 4 pi over 18. Same thing here. Notice the theme. When you do complementary angles, you take the original angle and you subtract it from 90 degrees, or in this case, pi over 2. Okay, and that's it, how we do these. So for a right triangle, we know we have the Pythagorean theorem. We know that the two other angles will always add up to be 90. And keep in mind, this is for every right triangle out there. You already knew the Pythagorean theorem worked for every right triangle. That A plus B equals 90 was also true for every right triangle. As long as you have a right triangle, that's going to be guaranteed. So now we're going to use the figure, and this is where it gets interesting because things are all over the place. If B is 4, capital A is 35, and we need to find A, C, and B. Okay, this is where we start really using our trig here. So keep in mind, label-wise, if I have a triangle like this, and if I call this B, the opposite side is always the lowercase b. If this is A, the opposite side is always that, and then the one always opposite to the the right angle is always going to be C, my hypotenuse. Okay, but if I was to have a triangle with different lettering, so it's not always A and B in those positions, let's just say, for example, this is B. and that's A, then that's lower A, that's lower B, which is kind of non-standard for what you've been doing. So just, you gotta not automatically assume something is in a certain place. You have to make sure you draw the picture correctly. So now we need to figure out something. They want to find out a, little c, and angle B. Well, the easiest one is angle B. All right, we know that we can subtract that 35 from 90 degrees because it's a complement, and there's B is going to be our 55 degrees. So you can add that to it. Now we have to find other things, and this is where our trig actually comes into play. All right, so remember, the tangent of 35, this is one of many options, by the way. Tangent of 35, so here's my 35 right here. The tangent of that is this over this. Remember, opposites over adjacents. So the tangent of 35 is a over 4. All right, so I'm just going to go with that one for a second. We'll come back to this cosine one. From there, I can go and say 4 tangent of 35 degrees equals A. And now to solve for A, I just put all of that in my calculator and I can get the answer. And that's what we're doing here. So same thing with the cosine. Oh, sorry, go back. Okay, so the cosine of 35, if they took the cosine of this, remember, it's adjacents over hypotenuse. We would get that right there. 4 over c. And then same thing, I would multiply by c, divide by 4, and I'll show you that on the next screen here. Just going to save this up on the right. So to show you how they're getting these pieces here. So you see, for the A, the thing I just erased, we had the 4 tangent of 35 degrees. So in your calculator, you take 35 degrees, take this tangent of it, take that answer, multiply it by 4, that's where you get the 2.8. For the C, it's a little weird. They didn't show how we got this, but I'll show you this. Remember, we have this right here. So I can multiply both sides by C. And then I divide by the cosine of 35 degrees on both sides. All algebra, just to make the cosines cancel. That's why we get C equals 4 over cosine of 35 degrees. Now on this one, I want to cut out of here and just show you how to write this or type this in your calculator, because sometimes we think it's obvious, but it's not. So let's go back. So for the first one, 4 tangent of 35 degrees, I like to start with the 35 degrees. Make sure you're not in radian mode. Hit the tan, then take that answer, multiply it by 4, and there's where we get our 2.8. Now for the other one, this is a little tougher. You can say 4 divided by 35 cosine, but realize on your calculators, most of your calculators, the moment you hit cosine, you're taking the cosine of 35 degrees. That's what this is. You have to hit the equals to finish the division. That's how we get the 4.88. So once again, it's 4 divided by this. So it's instantly showing you what the cosine of 35 is. So 4 divided by that, hit the equals. Got to hit that equals. Now be careful, because if you hit the equals again, it's going to keep doing the division and your answer is going to be wrong. So 4 divided by 35 cosine, 1 time equals, and that's how we get our 4.88. So in case it wasn't completely clear, I wanted you to see that. Okay, so show you a couple more slides here. Find if A and B are 4 and 2, find CA and angle B. All right, now this one's a little different, okay? Because now we can't use the 90-degree complementary angle because both angles are a mystery. What we can do is our Pythagorean theorem to get that third side, and you see we get this root 20 or 2 root 5. So that's normal, that's C. Okay, now we're going to use angle A. The tangent of A is 4 over 2. So remember how tangent is. From angle A, always center yourself on the angle you're talking about. Tangent of A is opposite over adjacent, 4 over 2. So we know that the tangent of A equals 2. from here. I just did the division. But now is where our inverses come in. We've done inverses enough times. This becomes that right here. The inverse tangent of 2 is A, and maybe we'll see it. Okay, use a calculator and you get 63.4 degrees. So remember, inverse tangent is telling you an angle. We've known this. We've talked about that. Go back. A is equal to inverse tan. A is an angle right here. So when you get an answer, make sure you answer it in terms of an angle. So once again, let's get that calculator out and make sure we're all understanding how to type this in. Okay, so inverse tangent of 2. I hit my 2, I hit my second or shift button and I hit inverse tangent, and I'm in degree mode, so when I get an answer, this is degrees. There's a 63.4. And then the last part, remember that they're complementary angles, so if you know A is 63.4, you just take and subtract that from 90. I'll put a minus here and add 90 to it. As long as you get the difference, 26.56, round it up to 26. So that's how we're getting that part. Okay, so let's look at another example here. Okay, find the inclination. Now we get our little word problems. And these always look worse because you guys see a picture, you see real life stuff. Don't worry, it's the same kind of thing. Here's the deal. My one trick I'll tell you, make a triangle. As long as you can take the information from the picture, like this case, or the information they tell you, and draw a picture, you're going to be fine. So straight trail leads from the Alpine Hotel to an elevation of, the hotel is at 8,000 feet to a scenic overlook that's 11,100 feet. The length of the trail is 14,100 feet. What's the inclination of the trail? That is, what's the measure of angle B? So first, everyone see where this 3,100 came in. Because you start at 8,000 and you go up to 11,100, that difference in rise is 3,100. That's the height. The hypotenuse is the straight walk, 14,100. Now we have to go figure this out. So all of this is to make one triangle. So I'm going to draw the triangle without the picture. This is 14,100. This is 3,100. And this is the angle we're trying to get. Now, ideally, in a perfect world, what we're trying to do is, like the last problem, I need to know this angle. I need to make a trig function. I need to find some trig function. And you can get that side if you want with the Pythagorean theorem, but know the context of what they're asking for. They just want this angle. We don't care about that side. We have enough information. I just have to pick the right trig function that uses these two. So remember, I have the opposite, I have the hypotenuse. I'm thinking, okay, what uses the opposite and the hypotenuse? Oh yeah, sine does. Sine of B is going to be 3,100 over 14,100. So if I can get that, and I'll go to my calculator here. Of course, I lost everything, but okay. I don't know why I lost it all, but finish writing what I was doing here. So we're going to plug in that answer right there and take the 3,100 divided by 14,100. You're going to get a decimal, hit the inverse sign, and you get your angle measurement of 12.7 degrees. Just make sure, excuse me, as long as when you're working out these problems, just make sure you're always putting in angles. If you're finding an angle, make sure you answer in degrees. Okay, lighthouse stands 100 feet high on a hill 300 feet high. On a hill that's 300 feet high. Okay. Trying to figure out what this picture is. Okay, above sea level. The brochure states that the light can be seen on the horizon 26 miles distant. Verify the accuracy of this statement. Okay. Okay, I think I know what they're asking for here. So the good news is they did give us this picture here. So the central angle positioned to the center of Earth, radius 3,000, 960 miles satisfies the equation. So what this is this is the Earth, this big arc. To the center of the Earth, excuse me, is a 39.6, and going all the way to the lighthouse is the same. I don't know if I like the way they drew the picture, but okay, we'll figure it out. So the cosine is all of this, all right? So the trick here is, and let me draw this picture a little better. Let me just add details so you can see what they're supposed to say here. This 39.6 goes from here to here. And that's the distance from here to here, to the surface of the Earth. Then there's another 400 feet. So you see, why is there this 400 over 5280? Because it's 5,280 feet in a mile. So this is the fraction of a mile that you go up the lighthouse top right there. So you don't just add 400 to that. Don't make that 4,360 miles because the lighthouse is not 400 miles tall. It's 400 feet. It's a small decimal of the whole thing. So, all right. Now, how we do this now is, so let me do this on a calculator to show you. Okay. So on my calculator, let's just do that bottom part, this length right here. If I take the 400 divided by 5280, we get that. So it's 0.075 parts of a mile. So 3,960. That's that length right here. To the top of the lighthouse, to the center of the Earth, is this 3960.075. That's also the distance, or sorry, so it's not much further than this distance right here. So we have our right triangle, and what we're trying to figure out here in the original question is, what's this angle? Okay, so the cosine of this angle, of this alpha right down here, is the adjacent over the hypotenuse, where the hypotenuse is slightly bigger. It's all that right there. So this little bit is what we plug in here for the cosine. So I'm going to see if I can do this all in one step. We take the 3960 divided by, and I'll use my parenthesis, 3960 plus 400 over 5280. And that's where we get that right there. Okay? So they rounded it to right this spot. But that's the thing we're going to take the inverse cosine of. So take the inverse cosine and, hope I did that right. Yeah. No, I didn't. Okay, here's what we had originally. I'm taking the inverse cosine of this, and this is where I get this 30.354. That's this first parenthesis. This is the number of degrees. You think about this. These numbers are almost the same. This answer, this ratio is almost 1. That's like the cosine of 0 degrees. It's almost a 0. You know, the picture looks like it's open, but it's really like this. It's like so small. Think of how big the Earth is. So the reason they multiply this by the 60 is, if you know how degrees are broken up into minutes and seconds, like hours. So 60 minutes, that's what that little hash is. 60 minutes is 1 degree. So if we multiply that 60 times this decimal, that's going to tell you you have 0 degrees in 21.27 minutes. That's how much that angle is right there. So that's what they're trying to illustrate there. So now we go back to an old formula, which remember was the length. Where's that picture? This S right here, remember? That's that arc length. We had this formula a couple sections back, is R times theta. So we know the theta is that, go back. The theta is this 0.3544 degrees. So we need to convert that into radians. All right, so how do we do that? Well, we know the radius is 3960. we need to take this 0.3544 and we multiply. I don't know how they got that, but I'll show you in a second here. All right, so that 0.3544, that's the number of degrees. So remember, let me write this up on the screen. We have 0.3544 degrees. How do we convert to radians? Remember, it's pi divided by 180 degrees. So I'm going to take this answer. I'm going to multiply it by pi. I'm going to divide it by 180. And that's how we get 0.0061855, or in this case, 0.00619 radians. We multiply that by the radius. And that's how we get the arc length to be 24.5 miles. Okay? So that's what's going on in there. That's how you can go back and you look at this picture. That's how they can say, if this is where the lighthouse is, you can see it when you are 25.6 miles around the ocean or wherever it was. Okay? So that's one of your more complicated ones. Emily, you're asking, do we replace the 0.008? Oh, that right there was the answer you got when we took, this right here. So when I did 3960 divided by 3960 plus the 400 over all that, that's the answer of what cosine is equal to. Cosine equals all of this. Trying to make sure I'm getting the same thing here. I don't remember if we got that 0.08. It actually doesn't seem like it's the right thing. I actually think that's a typo. I'm sorry. Yeah. It's supposed to be 0.999980870. That's just a typo when they did this. So it is the 0.9999 number that you plug in and you take the inverse cosine of that. So sorry, apologies to everybody about that. Your slides are wrong if you download them. That should be a bunch of nines right there. Okay. So I think I'm going to skip the last one just to make sure we get to some homework problems here. So give me a second. Okay, so now the bearings. This is one part that you might get this on homework. You hear people talk about north, south, east, west, northwest, southwest, all that. Just to be clear, when you're starting out somewhere and you're going directly north, obviously that's going up. So there's your north, there's your east. If you're going somewhere over here like this, and it's say 40 degrees over, this bearing, this vector right here, is considered north, and then what your turn was and which way you turned towards. So that's north 40 degrees east. Conversely, if I have a 40-degree turn this way, sorry, that's not a straight line, this would be north 40 degrees west because of that direction you go. Now, almost always you start with north or south and then you turn toward the east or the west. You won't say, for example, east 50 degrees north. Even though that's technically correct, you almost always are going to see it where they start north and then they go, or south, and then they turn one direction from there. So just like if I was to go, say, 10 degrees down this vector right here. So what it is it's technically south, and then you turn 80 degrees toward the east instead of east 10 degrees south. So that's south 80 degrees east. So that's just kind of a quick rundown of what they mean when they say these bearings, because they're going to give you bearings and you're going to have to understand what it means. And then they're going to have problems where you're going to have to answer that as well. okay? And you have to, it's like, I know which way it's going, now I got to figure it out, and that's what's going on here. So an aircraft takes off from Nashville Airport on runway 2 left, which has a bearing of north 20 degrees east. So remember, north, then turn 20 degrees to the east. It'd be somewhere right around here is the bearing. After flying for a mile, the pilot of the aircraft requests permission to turn 90 degrees and head toward the northwest. The request is granted. After the plane goes 2 miles in this direction, what is the bearing the control tower should use to locate the aircraft? So here's the picture. Okay, they started here, north 20 degrees east. They went for 1 mile, then they turned left 90 degrees, and they went for 2 miles. So you see, here's the triangle. There's a 1, there's a 2, and there's my 90 degrees. And all we know is that that's 20 degrees right there. That's all they gave us. Okay, so now we have to figure out what the rest of this is. Well, I'm not going to look at that 20 degrees yet. I'm going to get rid of this. And what I want to find is this angle right here. So think, from that angle, what do I know? I know the tangent of that angle. Let's just call it alpha. All right, or they called it theta, but I'll call it alpha. Is going to be the opposites over the adjacents. So remember, your right triangle is going to be all over the place. Okay, they're going to be all kinds of locations. You want to try to look at that and say, okay, well, where am I going? Don't worry about how the triangle is oriented. Just know that if I have an angle, this alpha down here, from there, the adjacent is touching it, the opposite is on the other side. So the tangent of that is 2 over 1. The tangent of alpha is 2. I want to find that angle, so I'm going to take the inverse tangent of 2. That's going to tell me my alpha. So we go on our calculator, and I'll save you the trouble because they have it right there. We get a 63.4 degrees. Now keep in mind, that's this entire angle right here is the 63.4 degrees. So that's this whole angle right there. We want to know what's the bearing, which is this dotted line. So remember how that works is you don't say north 63.4 degrees east because the part of that 63.4 is this stuff over here. Well, we already knew that was 20. So all I'm going to do is subtract 20 from it. Here's 20. This part is 43.4. So my bearing is north 43.4 degrees east. That's the direct line of where the plane is at that exact moment. Now, obviously, as the plane keeps going, the bearing will change and it's going to keep following it, but that's how to find it right at that one spot in time. Okay, so for the last 20 minutes, let me just try to do a couple more of these problems from the homework. Let's see. And like I said, a lot of this is familiar because you've already had it. They're just kind of twisting some things around. So you have an acute, theta is an acute angle. Solve for the equation tangent of theta equals 4/7. Express your answer in degrees. Well, that's not so bad because if I'm looking for the tangent of theta, if I know the tangent of theta equals 4/7, then I know the theta equals the inverse tan of 4/7. And this becomes completely a calculator problem. So I'm going to go take the 4 and the 7s, divide 4 by 7. We get this, and take the inverse tangent of that. I already have it on the screen. We get 29.74488 degrees. Round to 1 decimal place. So 29.7 is what I'm going to put here. And there's our answer for number 27. All right, let's look at 31. Determine if the following statement is true or false. In a right triangle, if 2 sides are known, the triangle can be solved. Now, what they mean by solved is if you have a triangle, you get all 3 angles and all 3 sides. So they told us we have a right triangle. All right, so we have that. And they give you 2 sides. So it doesn't matter. Let's say we have that side and that side. So we know for sure we can get the third side. The question is, can you get the angles? And remember, let's just say that's a theta. I can use these two right here to say, well, what's the inverse tan? And just like the last problem, I can get this theta, I can get that theta. As long as you know that, then you can solve the triangle and you can get the answer. That's all that one was. Now, on the reverse of that, if you know the angles, can you get the sides? Well, that's a little bit of a different story because sides will automatically guarantee you can get the angles. But if I have angles of, say, let's call that 30 and 60, if you don't know any of the sides, you may not be able to get the angle, any of them, because see, here's another triangle of 30, 60, 90. I had that backwards, sorry, but see how these could both be the same angles, but if you don't have any connection to a side length, you cannot guarantee you're going to get the answer. You're not going to be able to solve the triangle. So if you know the sides, the answer is yes. If you know the angles, the answer is no. Okay, number 35. Find the exact value of the expression. Do not use a calculator. Okay, how are we going to do this one? This one, okay, so what they want us to do, I'm trying to make sure I'm not going to jump too far ahead and give you a formula you haven't had, but think of what is known, okay? So we don't have this. We're thinking formulas. And let me pull up the one that I want you to see. And I don't know, like I said, this is section 8.1. So obviously we know the stuff that we just learned, the subtraction ones. Remember those? And I was hoping not to use those because that's not exactly the goal of this problem. But you remember this one? Where's it at? Right here. So we can definitely do sine minus sine, but we don't have one for sine minus cosine. So now I know what I meant to do. It's a lot easier than I'm trying to make this out to be. Apologies. So what the formula was that they did give us. Remember, when you have sine of 70 degrees and cosine of 20 degrees, remember the complementary angle idea? If I know the sine of 70, that's exactly the same as the cosine of 20, the complementary angle to that. So cosine of 20 minus cosine of 20, that's going to give me a nice 0. And there's my answer. Now, this is one where you could have plugged that into your calculator, and yes, you would have gotten the same thing. The idea, though, was just to recognize that complementary angles. Anytime you see two angles that add up to 90 or 180, probably something special is going on, something easier than you might have anticipated. So, a lot easier than I was thinking. All right, let's look at number 39. Same kind of thing, right there. I see, wait a minute, these two angles, 14 and 76, they might be special. There might be something going on that one as well. So try to see where we go on this. So I have a tangent of 76 degrees. No calculator, okay? So what I do know from my formulas is that if I have the cosine of 14 degrees, it's the same as the sine of 76. But also, I know the cosine of 76 equals the sine of 14. Okay? So which one do I substitute? So let me do this one first. Let's say I keep that one and I move this one down to sine of 14 degrees. That helps me a little bit in the fact of I get this minus the cotangent of 14 degrees. And I can finish this problem because I could say, well, wait a minute. I remember also with my complementary angles, this is the same as the cotangent of 14. That's degrees, by the way. So I'm going to get a 0 right there. Now, the faster way would have been, instead, if I took this and changed the top to be the sine of 76 over the cosine of 76, I would have had that to be the tan of 76 degrees, and I would have had tan 76 minus tan 76. Either way, we're getting a 0. So there's not a lot to these. It's just, did you identify the actual identity? Did you recognize that that is true? Okay, and like I said, the hint is as soon as you see complementary angles, something unique is going to happen here. All right, number 43. Use the right triangle and given information to solve the triangle. So we know A is 10, so I'm just going to write right on that triangle. So there's my 10. And I know B is 23 degrees. And let's try this. Let's make this a little bigger. And to me, the drawing of your picture is one of the most important things because it's just going to tell you a lot of this, of what's going on. You get to visualize it. So we know the B is 23 degrees. We know the A, I'm sorry. This is what they gave us. And of course, remember, you know A is going to be the opposite of capital A. That's a 10. And from here, we got to find everything else. Well, the easy one is I can get A up here. It's the complementary angle of the B. So that should be a 67 degrees. And again, everyone see, we do that. We subtract 90 minus 23. That's how we get our 67 degrees. Okay? So now it's a matter of let's go find the other two sides. So I just pick, I can pick any angle. It doesn't matter. Let's say I go with the sine of 23 degrees. Now look at the triangle. Okay, and I picked this on purpose to show you something. Sine is the opposite over the hypotenuse. Now the problem is, wait a minute, I don't know either of these. I have two unknowns, so I can't use that right now. Let's try the cosine of 23 degrees. That should work because that's going to be 10 over c. So I have c times cosine of 23 degrees equals 10. C equals 10 over the cosine of 23 degrees. And I should be able to do that in my calculator. So 10 divided by the cosine of 23 degrees, and don't forget, remember, hit the equals. We get a 10.86. All right, now I got to somehow figure out the B, and I'm down to 1. So it's not going to be that difficult to, I have everything else solved for, but I got to get that actual B. Now you can do the thing I did earlier, the sine of 23 degrees. Now I know it equals B over the 10.86. Now, I don't like doing it this way because this answer we had to find and it's rounded, so I lost all this stuff. So my answer is going to be slightly off. When possible, I like to stick with things that I already know. So like if I go to the tan of 23 degrees, I can call that B over 10. So the I'll do that again. Tangent of 23 divided by 10, multiplied by 10. That's what I'm trying to do here. Multiply both sides by 10. We get 10 times the tan of 23. That equals B. Now you see I'm only sticking with numbers that I originally was given, not ones that I found, because let's say I screwed up and I messed up this C value. Now I'm going to compound that mistake when I find B, so I'm losing both of them. So even if I mess this one up, when I do this other problem, now I'm going to get it, it's like starting over. I don't have to worry as much. So the tangent of 23 times 10, we get our 4.24. And now let's just write down what they've asked for. They want to know B. So we just got B, round to the nearest hundredth, 4.24. Now they want C, also to the nearest hundredth, 10.86. I think I rounded that correctly. Hopefully I did. And now angle A, that one wasn't so bad. That was our 67 degrees. And that's it. Okay? You just have to do it. It's multiple steps in one problem. That's what they're doing here. But these are the ones that really, these in the 40s, they summarize if you really know this chapter or if you still have some work to do. Okay, 47. Same thing. I'll go through this one a little bit faster since we already did one like it, but so we have A, we have little b, we have C, we have our 90 degrees, we have capital B, and of course, that's little a right there. Okay, they tell us A is 1, C is 3, and find everything else. Okay, so first step, I can do the Pythagorean theorem. Go with what's easiest. 2 squared root of 2. Okay, I can actually enter that right now. And I believe we established this. If you left it as a square root of 8, you're probably still going to get it right. But I'm going to, Oh, they want us to go to the nearest hundredth. Trying to go fast, and this is my problem. They actually want the decimal here. So let me give that square root of 8. All right. And 2.83 is my nearest hundredth. Better? Yeah, there you go. Okay, now for the angles. This is going to be a little bit more work. We're going to involve some inverse trig functions. 2 point, what did I say that was, 83? Okay, now I got to make a trig function. I don't know if I'm looking for A or B. It doesn't matter. But what I want to start with is let's try to use the ones that, remember I told you the ones that were given to us in the beginning. So maybe I'm going to say for B, that looks like the adjacent over the hypotenuse. So I'm going to say cosine B equals 1 over 3. So therefore, B is the inverse cosine of 1/3. So in my calculator, take your 1 divided by 3. Take the inverse cosine of that, and there's my angle, 70.5288. And they still want A. So now I'm going to subtract 90 from it. So subtraction, add 90, however you want to get to it, as long as you know it's the complement, we get a 19.47. And they want us to be to the nearest 10th for these. And that's another one, because if I typed in 19.47, let's do that. I'm probably going to get it wrong, even though it's more correct. Yep, so round to the nearest 10th, 19.5, and now we're good. And last, B to the nearest 10th, 70.5, and there's our answer. So again, just a series of steps on these particular problems. Okay, so I'll pick up with the rest of these next time. I think there's only a couple more left I have to do. We get a little bit of a word problem. So let me start with these in class on Wednesday. You should at least be able to get started on this homework. You can almost complete this homework. So little review with your assignments. So like I said, we have these 3 problems I'll do next on Wednesday's class. But for your assignments, remember your quiz number, where are we at now? Number 6 is due tonight. So if you haven't done that, do that one. We're on homework 7. Quiz 7 is due on Friday, but you should be able to do most of it now once your other quiz is finished. And then we'll finish this up. We'll do 8.2 and 8.3. I don't know how much I'll get done with both of those on Wednesday, but I'll do as much as I can on Wednesday, and whatever I don't get done, I will wrap up on Friday and do a little review of the quizzes. So I'll probably do a quick quiz 7 review after we do those last couple problems on Wednesday. Then we'll start 8.2 and go on from there. So keep working. As you see, this stuff just keeps rolling. We're still doing our 2 quizzes a week, our 2 homeworks a week. You have to just stay up to date on this stuff. You know, it becomes pretty regular, but 8 weeks worth is a lot. It's easy to just take a break, and then all of a sudden you're way behind. Then you're playing catch up. So try your best to stay as ahead of this as you can. Do anything you can. Even if you know you don't have enough time for an entire homework assignment, you have 20 minutes, do 20 minutes worth of homework. That's 20 minutes less you'll have to work on at the end at the deadline. So keep working. Hopefully everything's going well. Shoot me more emails if you have more questions, and I will chat with you guys, or I'll see you guys all on Wednesday morning or Wednesday at noon. So have a good one.